Hi class, this is Miss Ryan, and we are going to continue our unit on quadratic equations by learning about how they're used out there in the real world. First, I want you to go back to the lesson where we learned about how to graph quadratic equations. What kind of shape does the quadratic equation form? So it forms what's called a parabola, where it either goes up like a cup, like a U shape, or it goes down like a frown, which is just an upside down U. So I want you to keep that in mind when we're reading this article. Now let's read this article that talks about real-world applications of the quadratic equation. I want you to take notes in your math journal and just write down any thoughts or ideas that come to your head, and then I also want you to write down the applications that we read about in this article. So almost every day at least one student will ask me, why do we need to learn this, Miss Ryan? When are we ever going to need this? So let's read this article and find out. Here we go. How little did we know of the quadratic equation and its beneficial correlations with everyday life? Quadratic functions are more than algebraic curiosities. They are widely used in science, business, and engineering. The process of discovery started from the 16th century. The world has changed, and so much can be attributed to the quadratic equation. It's an unending story from the orbits along which the planets moved around the sun, to the invention of the telescope, to the unfolding of the moons of Jupiter and the phases of Venus. The parabolic shape today works for the bowl of a giant radio telescope, a shaving mirror, and a satellite TV dish, and at its foundation lies the quadratic equations at the heart of modern communications. A very significant discovery is the link between quadratic equations and acceleration. When related to a very important application is to find the stopping distance of a car traveling at a given velocity. A very common and easy to understand application of a quadratic function is the trajectory followed by objects thrown upward at an angle. In these cases, the parabola represents the path of the ball, or rock or arrow, or whatever is being tossed or thrown. The U-shape of a parabola can describe the trajectories of water jets in a fountain and a bouncing ball, or be incorporated into structures like the parabolic reflectors that form the base of satellite dishes and car headlights. Quadratic functions help forecast business profit and loss, plot the course of moving objects, and assist in determining minimum and maximum values. Most of the objects we use every day, from cars to clocks, would not exist if someone somewhere hadn't applied quadratic functions to their design. Okay, let's stop here and talk about what we've read so far. Let's talk about the different applications of quadratic equations. Look at your list and tell me what you read about. So, quadratic equations are used in science, business, and engineering. They're used in calculating orbits of the planets, and they're also used in the invention of the telescope. How many of you have ever used a telescope? They are also used in the creation of a shaving mirror and a satellite TV dish. How many of you get cable through a satellite TV dish? They're also used to calculate how far an object, such as a car, has traveled. I'm sure all of you have been inside a car or even maybe have driven one. So how many of you play sports? Now every time you throw a basketball or a baseball or a softball, you'll know that you can use a quadratic equation to calculate how far it's traveled, how fast it's traveling, and how long it travels for. I hope after reading this article and watching this video, you'll have a better understanding of what quadratic equations are used for, and that I have cleared up a little bit of confusion on why you need to learn math. Thank you. Have a good day. Bye.